second
You know, like a light year has to be
45.
something.
45 years, which
So-
is...
What is a light year?
No, that's
How far it travels in
Like,
1
it's
year.
how far
that's
it
how
travels.
fast light travels, right?
Yeah, but then it's the distance of 45 light years, so
Yeah.
it's
So
this
3
how fast it
3
goes
times
for
10 to
45
the
years.
8 meters per second is how fast light travels.
And 45 years would be converted into, how calculated?
So
Years.
there's 3,600
45 years.
an hour times 52 weeks, right?
Okay, so,
365 days.
wait,
We gotta go.
how many seconds in a day?
An hour,
How many seconds in an hour?
3,600 times
Do the
24.
opposite.
Times
Did I do it?
24.
I don't know how.
That was 3,600 seconds in a day.
Yeah.
An hour, 60, 60.
60, yeah,
60,
30
yeah.
60 seconds in
Go.
a minute.
Oh, okay.
Hour,
60 minutes in an hour, so that's
365
3,600
days,
in a year.
and then 45 years.
Okay, 45.
Seconds.
Okay.
But the one thing about this problem is that we need to figure out.
So that's like 1.42 times
of slave labor.
what does that say? 1.42 times 10 to the 9? Or it's gonna fall.
Nine?
I think so.
9?
2, 3, 4, 5.
Yeah. Okay. Mine's already in scientific division. Okay, then times that by 3 times 10 to the 8.
And then,
3 times 10 to the 8.
Yeah.
And then from Earth,
4.26 times 10 to the 17.
4.26 times 10 to the 17.
Yep.
and then
Meters.
and then the 523 nanometers. That's the from Earth. If you measure the light or wavelength, that's how big it is from the star.
Okay.
Yeah, you know.
That'll be 7.
And then we're trying to measure the frequency and wavelength that the star would emit if you're standing on Earth and you look at that star.
Okay.
Yeah.
Once you finish it says the Doppler
But
equation.
isn't the dot but how is like that sound? If this is about sound, how is that sound?
No,
Should we
because
down-
it's asking for wavelength and it's asking for frequency. So we have the velocity
We have the wavelength too.
and we have the wavelength. So so it's just asking for a certain frequency or a certain wavelength. So
Yeah.
so
So the equation for the
Okay.
we're finding frequency first.
isn't it strong? We have to figure out which equation to use.
Wouldn't it be the Doppler effect when both listener and source?
Source may be moving. So is listener and source moving?
Yeah,
Well, the
because
sun and the
What
earth
what
are
is
moving.
what does it
Well, we
do?
don't know the speed of the star.
No, the sun and the earth
What
are
is the source
traveling.
and what is the listener?
The
So
source is
the listener is the person on the star. So basically the
on Earth, because the person's on Earth.
the source.
if an astronomer on Earth measures light of wavelength
Should be the
from
star.
the star.
The source is the star.
The star is not moving.
And the listener's on Earth.
Yeah.
Is the star been moving?
Yeah, everything moves constantly in space.
Well, how can we move towards the star if the star
Yeah,
is
my hand is
moving?
getting bad still.
Because the sun is a star.
See, look at this.
No, because in the beginning
Oh.
of the equation it's saying that the sun and the earth with it are
But you
traveling
keep up with
at
that.
certain kilometers per second.
No, but it says the sun and the earth are
Okay,
traveling
okay,
at this velocity towards a star
Yeah, just
that
that's
is
right. So we're not
45
moving.
light years away. So
The star is not moving.
we have to figure out what is the source and which is the listener. So I think the source is the sun and the earth going towards the star, and I think the star is the listener.
Star is
I
the
think.
listener?
Strikes.
And so all these doors.
Well, let me see, okay. Well, the astrometer is on Earth.
Fine, just
So he has to be the listener, because there cannot be a listener on a star.
Listener, no.
Okay. I'm just trying to figure out who this is. So I think maybe, okay.
Okay.
So
Yeah.
the sun and the earth
Are the listener.
are the listener.
Yeah.
And the star is the source.
Oh, you can replace them. Yeah.
Yeah.
Yes.
And then the listener is sun and earth. And then the person listening is on earth. So,
That's why it's a listener.
yeah, listener.
That means the listener has the velocity, but the source doesn't.
I'm pretty sure we're supposed to use equations for point.
No, because they're not both moving. Just the Earth and the star are moving. The star is not moving.
There's an equation when one was moving.
I'm sorry.
Moving source. No, the star isn't moving.
Well, do you have the speed of the other star? Do you have the speed?
No. Moving.
No.
Moving.
It didn't have the speed, but it said,
Moving listener.
but it said the star is 45 light years.
We'd use
light
this
years away.
equation. FL equals velocity plus VL. Oh.
Well,
Velocity.
well, V of source is 0, so it's okay. Then it'll be the same. It should be that.
So it's just frequency equals velocity over wavelength.
Yeah.
But if the star, if you're saying the star would be 0, then it was
It's not this equation, it's this one.
okay.
Okay, okay.
Okay, so do you want to write that equation?
Sure.
FL.
You can erase that whole,
Oh, No. I don't
Sure you
think
need it?
the person on Earth
Yes.
has anything to do with anything. It just says, it states that if an astronaut or astronomer on Earth measures light of wavelength, it's just an astronomer
Okay.
measures
Oh, yeah.
light of wavelength. The thing is actually an observer at rest with respect to the star. Does that mean? So that's the person listening. What frequency
So
wavelength
you're
with an
listener.
observer
Oh.
at rest? So that means one thing is moving and he is not. The listener is not moving. He's at rest
Well,
or whatever.
he-
So what's the listener is at rest with respect to the star?
over
So we have to figure out
Wait.
which one's moving.
all of
then.
it.
All?
Well, basically, the last sentence
All of
is saying
lambda.
that the person standing on Earth
Is
and then
not moving.
Lambda.
and then the star is emitting a wavelength and a frequency.
The person on Earth
Lambda?
is not. I
No,
don't know if it's on
the
Earth.
star is emitting a frequency, and then now you can see that by like seeing a little dot in the sky.
Yeah.
That's how long it took. So we're trying to
That's-
find how long, what the frequency and wavelength was, until it reached Earth, until we could see the light. That's what we're trying to measure. But I don't know how to. If only one of them's moving.
I don't know if it really matters what we use, because we have a velocity, we have a wavelength, just plug it in and see if we get an answer. Because like, it's just a V, it's just a wavelength. It's not like we have two to choose from.
Well, what's the speed
Is
of sound?
in this, is it one thing is moving, one thing's not?
Is the speed of sound the same thing as
Is
speed
that
of
an equation?
Yeah.
Okay, try it.
No, speed is not the same.
So the velocity is,
Assuming that the V is the speed
what
of
is the
sound.
velocity?
Well, then you could just put V with the speed of sound or V with the speed of
Is
light.
that one?
Right.
Is this the velocity, right?
And speed of light is 3 times 10 to the 8.
That's the velocity, yeah.
2.0.
That's like 7 meters.
And then divided by wavelength, which is what?
Wavelength is
Well, V without the step, V by itself should be 3.0 times 10 to the 8. And then V of listener should be,
So 523.4 nanometers is that times.
because yeah, it should be the speed of light.
That's a given. Yeah.
Isn't it?
Oh, 9 to
positive?
the, 10 to the negative 9, yeah.
Negative or positive?
Nano, it's smaller. Just that number, but smaller, or larger, it's supposed to be larger
Times 10 to the 7.
than that.
So I got 3.82 times 10 to the 13.
Yeah, that should be the right point.
For what? For what?
Times 10 to
Divided
the
by-
negative 9.
Yeah, yeah.
We're trying to,
But that-
523.4 nanometers into meters. So it's that times,
Because it's kilometers.
Oh, yeah, yeah.
Switch it to meters.
we're changing that to meters.
What was that? I got 3.82 times 7 to the 13.
To the
Is that
negative
right?
13? It should be
Yeah.
negative.
Positive.
It should be positive 13, because
I'm
now
pretty
it's
sure
already going to meters.
523.4 now.
Nanos is negative 9.
Oh. Never mind.
Nanometers is negative 9, so it should be
Nano-
5.234
Yeah,
times
sorry.
10 to the negative 7.
Yeah, it is.
And it's positive.
Okay,
Thank you.
5 point.
Because the average is positive.
Yeah.
Oh, no,
No,
5
at nanometers?
Yeah.
Times 10 to the
When it-
negative 9.
No, but then I just did 5.234 instead of 5.234.
Because like, if,
Yeah.
Yeah, well, it doesn't matter either way.
In
If it's,
nanometers,
if
if
it's there, change it
nanometers
to
is
9.
smaller than meters,
There.
would the answer be larger in meters or smaller? It should be larger, because nanometers is smaller.
It turns in nanometers, it'll be larger than meters.
Jerry, can you plug that in?
So the answer is, no, I think that's the wrong answer.
Well, just try.
Oh,
and
I
see
forgot
what
the
it is.
first part. I forgot the adding.
No, okay. Here's my question.
We just did this
If
figure?
it, since the
No.
answer is in nanometers, in meters, wouldn't it be a larger number or a smaller number?
Way smaller.
Smaller.
Way smaller number, that's wrong.
No,
No, no.
5.234 times 10 to the negative 9.
We're just plugging it in.
How we do that? I don't know. Where'd it go?
But would that be a small number or?
That's a small, way small number. 10 to the negative 9.
Okay.